Hi, I'm Pat Kelly. Okay, in this problem they give us a function f of x equals 1/8 in this case, and then they give us the closed interval 0 to 8. And the directions say to use a graphing utility to graph the function, and then we're supposed to determine if the function is a probability density function. Okay, so the directions say to start with the graph of the function using a graphing utility. So let me walk you through that real quickly on this function. This function might not be too bad, but you'll probably want to know this process for some of the later problems. So on my calculator, I'm just going into the y equals and putting in the function, which is 1/8, and then graphing. And not too much of a surprise that it's just a straight horizontal line. It's a constant function. The height of this function is at 1/8. And then we're going from 0 through 8. Keeps going, but what we're interested in is just between 0 and 8, this area there. Not to scale, maybe that's something that you would get out of the calculator too then. So my width of 8 is not going to be proportionate to that height of 1/8. Okay. But the graph of it, either from the graphing calculator or even just something that you might do yourself, is going to help us answer this question. Now back to the second part of the problem, the real question is this function a probability density function? So in order to check that, we're checking three things. We're checking that the function is continuous. We're checking to see if the function is non-negative. And then we're also checking the integral, the definite integral from a to b of the function dx. We want to see if that equals 1. Those are our three properties of a probability density function. And so for this problem, where we're asked to determine if this function is a probability density function, we have to check these three conditions. So the graph shows us that it's continuous. A straight line didn't pick up the pencil from 0 to 8. The graph also shows us that it's non-negative. Between 0 and 8, the graph is entirely above the x-axis. The y values are positive. So we've got a nice check mark there, a check mark there. So the rest of the work for us is to check that integral, see if it does equal 1. So for this problem, our integral from a to b, the limits are 0 to 8. 0 as a lower limit, 8 as an upper limit. And then f of x, just that part right there, is that part right there for us. It's a constant function, so it's just 1/8 as the function, and then dx. I don't want to write down the rest of it because that's what we have to see. See what it equals, see if it equals 1. So now we're doing the integral, the definite integral from 0 to 8 of 1/8. In this case, the antiderivative of 1/8 is 1/8 x. And we're doing a definite integral from 0 to 8. Okay. Real quick check again with those antiderivatives. I got that one quickly because to check it, you can go backwards, and if you ask for the derivative of 1/8 x, you should get that function in the middle, which is 1/8. So that's my antiderivative, and my definite integral now. I just want the fundamental theorem of calculus. I want to put in the upper limit of integration, that 8, for x, and subtract, plugging a 0 in for x. 1/8 times 0. It's my fundamental theorem of calculus step. Now it's an arithmetic step. 1/8 times 8 is 1, minus 0 equals 1. And so back to our three conditions. Is it continuous? Is it non-negative? And is that integral equal to 1? It is. So our three conditions to be a probability density function are all met. So my answer is yes. This is a probability density function. The directions also say if it's not, state what condition was not met. So for a different problem, if it wasn't continuous, or if it was not non-negative, if it was negative somewhere, or if this integral didn't end up equaling 1, I would say no, and then just cite which one of those went wrong. Okay. This one worked out though, so our answer is yes. Hopefully that helps. Thanks.